Team, could you please play the videos?
We live in a world that continuously reinvents itself. A world with visionary ideas, inspiring concepts, and smart answers to key questions of our time. How can we preserve our environment? How will our mobility needs be met in the future? How will we communicate? And how can we protect our data? Microelectronics gives answers to these questions. They are the link between the digital and the real world. Semiconductors from Infineon enable technologies to achieve more and consume less, while being accessible to everyone. Our values capture this mission. Commitment, innovation, partnership, performance. We make life easier, safer, and greener for a better future. Infineon, part of your life, part of tomorrow.
The man has always tried to tame the fire, but it still remains a terrible force and a threat. Faced with an emergency, people do not know what to do. How to protect yourself and your property? Epitous solved this problem. The association Epitous began its history in 1991, and today it has become one of the largest Russian developers and manufacturers of fire extinguishing equipment and systems for various purposes, starting from an idea and development of articles drawings to their mass production. The company's manufacturing facilities allow to create fire extinguishing installations for a variety of objects, as well as actively conduct research and testing in the field of firefighting. Thanks to the qualifications and experience of Epitous specialists, the creation of products takes place entirely within the enterprise. All materials and components are produced in-house. The closed cycle of development and production ensures the highest quality and optimum cost of production. Epitous carries out design, installation, and commissioning of works on its own, and also maintains and repairs electronic devices and fire extinguishing means. Products of Epitous are represented by the broad line: powder extinguishing modules, self-activated powder fire extinguishers, fine sprayed water fire extinguishing modules, generators of fire extinguishing aerosols of various modifications and technical characteristics, and automatic detection and fire extinguishing systems based on them. The association Epitous is trusted by the subways of the largest cities, Russian railways, urban public transport institutions involved in passenger transportation, Russian maritime and river registers, private companies, and owners caring for their property. Epitous fire extinguishing systems are installed in many cities of Russia. The products of the company in the field of powder and aerosol fire extinguishing are also of interest abroad. Epitous products are exported in dozens of countries around the world, and the geography of deliveries has been expanding from year to year. Epitous is constantly moving forward, increasing scientific and production capabilities. Epitous fire extinguishing systems and means are the concern of safety today, for the sake of a happy tomorrow. Epitous saves property and life.
Hello, and a very good afternoon to all of you. I'm Geeta, and it's my pleasure to welcome you all on behalf of eMobility Plus and First View Group to this most awaited virtual conference, the EV Battery Management System Forum 2021, where we will have a holistic understanding of the battery management system for electric vehicle application from some of the experts and sector technocrats. As the need for increased capacity and lifespan of batteries continue to grow, creating a safe and reliable battery management system is the need of the hour. But there are a few questions in my mind. Why do we need a battery management system? Why is a BMS pivotal for EV batteries? How to select the accurate BMS for my e-automotive application? What are the composition and design requirements of a low-cost and flexible BMS? Well, my wait is over because I'm going to get all my answers through this event. But before we start our program, we would like to thank our partners for extending their support to organize this event. The first in the line is Infineon Technologies, a world leader in semiconductor solutions that make life easier, safer, and greener. Our second partner, Epitous, which is one of the main designers and producers of firefighting equipment with more than 25 years of experience. And lastly, we'd like to thank the Automotive Research Association of India for being the supporting partner and having a long association with us for the majority of our e-mobility conferences. So the time now is to start to set the tone for today's conference with the first panel discussion on the BMS overview and its application in e-automotive space. And to discuss this, we have our expert panelists, Mr. Pankaj Batra, Project Director, SARI EI, Integrated Research and Action for Development, Mr. Piyush Gupta, Founder and CEO, Lithium Power Private Limited, and he is also our session moderator, Mr. Manikandan, Chief Technical Officer, Hero Electro, Dr. Parveen Kumar, Senior Manager, WRI India, Mr. Milind, Automotive EV Professional, Mr. Manish Garle, General Manager, Technology Group ARAI. Now, I would like to hand over the session to Mr. Piyush Gupta. Mr. Gupta, the screen is all yours.
Thanks, Geeta. Thanks for the invitation and welcome everyone. This is Piyush Gupta, and I work for Lithium Power, which is a battery swap company, as well as we manufacture BMS for various applications. I would like to start off this discussion, this very apt discussion around, how do we select a BMS and why is it important, with an invitation to all of my fellow panelists, so that they can introduce themselves and their companies that they work for and their specialization, so that all the audience gets to know them. Can I invite Mr. Pankaj Batra? Pankaj, if you could just give a small introduction about yourself and the organization that you're associated with and your interests.
Okay. Yes, I'm project director in the USAID funded SARI program, working for IRADE. IRADE is a partner of USAID for implementing this program of South Asia Regional Initiative in Energy Integration, which is facilitating cross-border trade in energy, including electricity in South Asia. But I am also chair of the ETD 52 committee of Bureau of Indian Standards, which is dealing with energy storage, and a number of other committees of BIS. So what I'm ex-chairperson of Central Electricity Authority, and I was dealing with this ETD 52 committee since before retirement. I was after retired in September 2018. We have, okay, I think that's all for introduction. Thank you.
Thanks, Pankaj. Welcome. I think next on my list is Manikandan. Mani, are you there?
Yes. Thank you. Good afternoon, one and all. It's very nice and immense pleasure to be part of this event, E-Mobility Plus, and I'm very happy to be here. So I'm very passionate about electric mobility industry. Ever since this industry is grooming, I've been following it up. I was with the Bosch, developing e-mobility components for 12 years, and then moved to Ola Electric. I was responsible for powertrain development for Ola electric scooter, and now with Hero Electro, where we are building a futuristic, e-bike platforms to take on most of the first mile, last mile connectivity on Indian roads and mass transportation for people. And this is about myself, and I'll be very happy and passionate about this, sharing any information related to battery, not only battery, and about all the electric mobility components, let's say. Thank you so much for the opportunity.
You're welcome. Thanks. Can I now invite Manish from ARA?
Yeah. Thank you. Thank you for the invitation. I'm Manish. I'm representing ARA. I'm part of a technology group. It's an internal R&D department of ARA. And today I will be sharing our experiences in developing BMS technology. So ARA has developed BMS technology. So I will share some of our experiences that we have generated through that development. Thank you.
Excellent. Dr. Parveen Kumar from WRI.
Thank you, Piyush. Good afternoon, everybody. So my name is Parveen Kumar, and I'm working as a senior manager at WRI India, and I'm working mainly projects related to the electric vehicle. And WRND is a global organization and research organization. In India, we are working closely with the central and state government along with the industry players to push for this help in implementation of this clean transport, and how we can work closely with the key stakeholders in removing the barriers in this transition. Thank you.
Thank you. And then we have Mr. Milind.
Yeah, good afternoon all. Myself Milind Mase. I have been working in this automotive field for last 18 years. I have been associated with Tata Motors, BMW, and Dixon. Now for last 2.5 years with this drive in the electric mobility field, I have been active participant in the battery and the electric mobility field. So now with this, this is I'm giving a good chance for getting an introduction with all of you. So thanks for inviting me.
Perfect. Thanks. Thanks for the introduction. I would like to start off this discussion with a very simple question for my fellow panelists. Why do you actually require a BMS? Right. So, Pankaj, can we just start off with you and start getting your views on, why is it required?
Yeah, sure. You have a battery and you require something to control it, to see that it operates in a safe manner and it's protected against various faults, as well as it operates efficiently. So it's basically the protection and controls of battery, or basically the brain of the battery, which is the battery management system. And it's actually often overlooked, or it so far did not have a standard of, even in IEC, International Electrotechnical Commission. They were making standards for BMS as a part of the lithium-ion standards. But BMS, irrespective of the chemistry of battery, is required because it needs to not only what I said about safety and efficient utilization of all the cells in the battery, but also giving information to the user about the state of charge, the state of health, because you would like to know, whether it's presently 80% charged or 40% or 30%, or so that you will get to know beforehand that you need to charge, if it's become too low, as well as the state of health, because the state of health means the battery, it would have, depending on the specifications of the battery, it may last for 7 years, 8 years, 10 years, 3 years, and there's a degradation as time passes. So people should know beforehand that it's coming towards the end of life. So these are some of the aspects of battery management system. And if you do not have a battery management system, you will be devoid of all this information and also of the protection and control of the battery. So it's very important. You would have noticed, or you would have got to know about various accidents which took place, especially in lithium-ion batteries catching fire and all that. Now, the BMS is supposed to protect against high temperature rise and cut off the battery in case there is an issue of rise of temperature. So it's a very important part, but it unfortunately didn't have a standard. And we in BIS thought that it is required that a battery management system must have a standard. So we made a generic standard for all electrochemical batteries. And we'll be going on into more details about for each chemistry, for the extra things that is there for each battery, each chemistry of battery. That's it. Thank you.
Absolutely, it probably is the most important thing in a lithium-ion battery, right? So you just start with safety, and you can't have a safety in a battery unless you have everything else is secondary. If you are not safe, you just can't use it, right? So that's how you start. So can I also, so thanks for your views, Pankaj. Can I also request Praveen from your views on, if you want to add something to what Pankaj has just said?
Yes, sure. Thank you, Piyush. So as Pankaj already covered that why this BMS is required in the lithium-ion batteries and how this is directly linked with the performance, cost, and safety. But if you just see in the broader perspective, in India, we have a very different climatic conditions, and maintaining a proper internal battery temperature is very crucial, and there BMS plays a very important role in monitoring the temperature and activating the thermal management for the better reliability and safety. And also, if you don't have a better control in the internal temperature of the battery, that can directly influence the performance of your vehicle. So we keep on listening about the drive range anxiety, and if your battery is not having a proper thermal management, so any deviation from the optimal operating temperature can reduce your the drive range of your vehicle. And also, BMS provides a lot of data related to health of the battery and other crucial data that helps in understanding in calculating the remaining life of the battery, and that is directly linked with the second life application of the battery and our end of life recycling planning. So unless we know all these data at the real time and understand how the things are going on inside the battery, that will directly impact the business models what we are pushing under the circular economy strategy for the battery. Because we in this transition from ICE to EV, we want to adopt a resource efficient path for this transition, and there circular economy strategy becomes a very crucial part, and for that we need all these information for the better planning. So of course, very good quality BMS and data we need for better planning, I feel. So that is my view.
So Praveen, you spoke about something very interesting. You spoke about not only safety, but essentially about how do you get data from the battery packs so that you could enhance the life of the battery or probably the second use of the battery, right? So that's about how do you get some more juice out of the batteries, right? So that's fantastic. Okay, but both Pankaj and Praveen spoke about safety. So let's just talk, for 5 minutes about the safety itself. So I see Mani, you are laughing, you're smiling, and so am I, right? So while we have both the panelists before me, before Mani, who stressed about safety, Mani, can you give me a number of how many batteries in India actually have temperature sensors right now today? How many?
See, more as far as I know, all these two-wheeler batteries which I come across with some of the manufacturers, like all the BMS brands, right now on the market, are having coming out with the temperature sensor. The number of temperature sensor varies from pack to pack, and that is also people have some strategy. People also one side there, it's a kind of a selling strategy, and my battery has 6 BMS, 6 temperature sensor, 4 temperature, something like that. But also there is a method for choosing that, and how do we go about defining this? The safety is very important according. That's the reason I was laughing. I think you also understood. So when we talk about safety, it is a kind of a very larger impact on the overall vehicle architecture, and also even overall the battery. And I think you also developed systems in this area. I think you have known these things in detail much better than me probably. But what I would like to stress here is, when you look at battery safety, we have to look at it three perspectives. The one perspective one is at the cell level. So what is the safety features, or how we ensure that the cells that we are used inside the battery are free from certain abnormalities or certain misuses or certain unwanted operating conditions. The point number one. The second focus could be at the back level. So what is the kind of systems and safety measures that we take care that when the pack as a system, it goes and fits inside any electric vehicle, and this pack is free from all the other unwanted situations. And third perspective is overall at the systems level. So you have battery inside and outside. Even outside you have a charger. Inside you also have some interconnects. You have bus bars, electrical bars. You have connectors. And your contactors, PDU, power delivery unit. So these are all the inside, components within the battery. This is very, very, should be very safely operating, and so as the monitoring, not only the internal system, we have to monitor how these external devices also interacting with this, the battery, and then what is this kind of safety mechanism implemented in terms of communication, in terms of the power deliveries, charging and discharging, that's what we say in technical terms, and what rate you charge, and what is the algorithm to charge, and what is the temperature, environment condition that will, you will monitor during the charging, so that the batteries SOC, SOH, and other typical characteristic is intact and maintained. Yeah. So for a safety, there are the three monitoring is very important: cell level, and back level, and the system level. When we talk about cell level, I want a little bit of stress on the cell level also, because while manufacturing, if there is some defects in manufacturing of the cells, we will not be able to do anything, right? Anything other than that, we should be able to monitor. So we know for sure. I mean, when I talk about BMS is essentially the basic fundamental purpose of BMS to monitor the cell's characteristic, like battery, cell voltage, cell current, cell temperature, and also the kind of pressure that gets built in due to this temperature variations, the delta temperatures inside the cells inside the pack. So these items should be continuously monitored. Along with that, you have internal resistance of the cell that has to be calculated, monitored continuously to make sure that your SOH, your health is correlated with the, you will agree that health is correlated with the internal resistance, and the drastic degradation. Degradation, there's a rate of degradation. Each cell, how it is going to degrade. I mean, when multiple cells you are using, and there is the impedance value of the cells is going to be different, and the degradation value also, rate also will be different. So how we are going to monitor the degradation from cell to cell, and so that the impact on the overall battery is also maintained at a particular level, right? So that is first thing. And the pack level, you have you using a lot of electrical circuits. You have a contactor, you have fuse, and you have the switching circuits. Yeah. So all these electrical, that we also have a lot of EMI, EMC tests that we test to pass through, right? And it is also going to directly, if somebody is handling the battery, what is the handling kind of a safety mechanism, abuse mechanism, battery abuse mechanism, nail penetration test, maybe at the pack level. People are now doing it even cell level also. This battery has to withstand the nail penetration. This battery has to withstand some temperature and the operating conditions. And we know that in India, we have extreme operating conditions, extreme temperature conditions. And that's the reason we are trying to see how we monitor the temperature. And not just putting a temperature sensor will solve the issues. We have to really study the whole system and simulate and how this behavior throughout the battery and see a holistic approach in deciding the temperature. These are the complete monitoring system as I was talking about, which some of the ideas that we have to build inside in the battery pack BMS, and BMS should have able to have this monitoring and sometimes even control solutions to take care of all these safety issues, and that is primarily important. That is what I wanted to convey. I think that's the reason. I think you also know, I also know, but I wanted to tell the audience that this is very important. That's the reason BMS is very important to the battery pack.
So let's get Manish's view on this. I'll ask you a very pointed question, Manish. Right? Again, let me put you on a spot here. I asked Mani the same question, and he didn't answer that question. He answered the second part of the question. How many BMSs in India? or how many battery packs in India, what percentage of battery packs in India actually have a sensor that works, a temperature sensor, a basic temperature sensor. And that's something that, Pankaj, you probably have to pay a very significant attention to on basis of what he says just now. Yeah, please, it's a pointed question.
Yeah, it is a really pointed question.
And if you don't answer, I'll answer it later on.
I think like to dodge your question and give some sort of other view, I think we need to educate people that what is the need of putting a temperature sensor? Does it have a value to customer and does it make a business sense? I think that people are not able to understand, particularly smaller player. The bigger player, they do understand the need of this. They understand the technology. I think what Manikanda sir was trying to say, and I will take it to limit, that people should understand that battery as a technology does like to operate in what is called a safe operating area in terms of voltage, current, temperature. And if you want to put safely into use, we must respect that operating area and operate battery within those areas. And for that, this thermal management, temperature sensor, good current sensor, all these are basic needs. I think there is a gap, particularly for a smaller people who like to import everything from outside and put it use, that they don't understand these aspects. And in fact, this was the reason why we actually started our own BMS development program, that when we started a battery research, we wanted to have good BMS, and we found it very difficult to have a good BMS, manufacture. And then we saw there is a good gap within India at an application level. It's not, people are not basically trying to understand why they should spend while designing a battery pack on a good BMS and or a good disk mechanism. I think this is the gap is there. I think you are well aware of these gaps. I think that is the reason that, and we should be able to educate and make particularly smaller people understand that battery, yes, it has its advantages, EV, XEV, but there are some inherent risks to this technology that we should respect, and we should develop our products by considering all these aspects. So that will be my comment on this.
Okay, still I don't have an answer. Yeah, let me answer that for the audience. Right, 99.9% of batteries made in India have a single temperature sensor, which does not differentiate between the charging temperature difference and the discharging temperature difference. Yeah, that's 99.9% of batteries manufactured in India, and 0.1% is my error. Yeah, so it's quite possible that almost 99.99% of batteries manufactured in India do not have a temperature sensor, when more than 60% of the batteries manufactured in India are NMC batteries. And the thermal runaway for NMC batteries is close to 60 degrees Celsius, which is the temperature which gets inside a battery pack during Delhi summer. I have personally seen 59 degrees Celsius temperature inside my battery packs in Lithium's swap network. Yeah, one degree away from thermal runaway. So again, so that's the state of industry that we're talking about, and understanding why a proper monitoring system. What does BMS do? It is first monitors and then you manage. You require sensors first for monitoring and then for management, right? So that's where we are. But Milind, from your perspective, how do you see industry evolving? Yeah, and what are the key issues that you see in adoption of good quality BMSs? And BMS is just a small part of the larger battery technology, but since we're talking about BMS, what are the key issues that you see in adoption of let's say quality components by the industry?
Yeah, majorly as per the evolution point of view, we have seen a long move ahead for last 2.5 years. Earlier, we were not even close to knowing this thing. Now we have a discussion in every forum, and we now talking about how to optimize the functioning of BMS and how to get the reliability and the quality of the performance better through it. So as far as adoption is concerned, everyone is now know that adoption is going on very fast pace in the India. And as far as concerning the key issues which we are right now having that how the battery pack should perform. Like it should perform the complete safely, and it should perform the life and the quality, and it's the reliability also. So all these factors require some monitoring from the inside also. If you see, there are sensors which are there for monitoring voltage, current, and temperature. But this should be precise enough to have, because these are the only things which are getting measured on the cell level. So everything depends on this. So the precision of this is very important as such. So the method of doing this measurement is important. Now with a lot of analog to digital converters, we can have a voltage measurement quite precisely, and that can be used for the different state, like how it can communicate to the person who is driving that vehicle, like how that state of health of the battery is there, how much range it will give. So that will keep on improving with the time being. But yeah, we are going on the same good pace from, from the adoption point of view on the EV.
Perfect. Perfect. Thanks. Thanks, Milind. So I would actually come back to Pankaj and ask another question around, since we've spoken a lot about the safety aspect, right? Which essentially is the core function for BMS. You know, from where I see, everything else is a bonus. If you make your product safe, you know, it'll work. Yeah. And I personally think you know, there is a lot of emphasis on SOH models. Yeah. From coming in from a BMS, but I think it's not fully understood. The SOH model probably should be coming in from the cell manufacturers. Yeah, a battery pack assembler or a BMS manufacturer or a BMS designer is in no way able to predict SOH for a BMS for a battery pack. And SOH comes in only from the cell characteristics and how the cell manufacturer expects the cell to degrade with different stresses that the battery pack takes. Yep. So again, it's debatable. It's something which has to be put as an algorithm inside a BMS. So to that extent, you need to have a manufacturer of either a BMS or a battery pack responsible for the SOH. But largely, you know, it has to come in from the cell manufacturer. Yeah, but coming back to Pankaj, in terms of you know, setting the safety standards, how are you thinking about you know, and how fast are we going to see some standards coming around the safety of the battery pack? Yeah, frankly, you know, I'm in the industry, and sometimes I feel extremely uncomfortable sitting on an electric vehicle, and I'm not talking about cars, I'm not talking about buses, which are actually very well engineered products. Yeah, but we are talking about the mass mobility products, which are two-wheelers and three-wheelers, and that's 99.9% of the Indian market. How far are we from actually seeing some safety standards being implemented, being drafted and then implemented?
So as far as battery management standard is concerned, in 2020, we published this IS 17387, which is solely on battery management system. And this contains all these parameters of charging and discharging temperature limits, charging current, maximum limit of discharging current, voltage, balancing for efficient balancing between cells for efficient utilization of the battery, and of course the parameters of state of charge and state of health. This is already out. Except that many people are not aware of this. So we did have a webinar by BIS on energy storage, which also had BMS battery management system standard last year, towards the end of last year, where we invited people from people who use batteries, manufacture batteries, and Yeah, so and people who set up people who erect batteries. So it's we did take out a webinar, and we also invited people from abroad, from US, and there were some people from Europe and some other countries. The idea was to showcase that we have taken out a standard on BMS, which is of course a generic standard for presently for all types of battery chemistries. But these are basic generic standards which should be there. The reason is that many people, as there is, this is an evolving process, the making of or coming out of new, there's still experimentation going on in new technologies of batteries. Various, of course, chemistries of lithium-ion, but not only that, many other chemistries are also coming out. So there, for example, we, by the way, introduced this as a new proposal in IEC, because IEC also doesn't have a separate standard on battery management system. They're taking it as a part of the lithium-ion. The battery BMS is part of lithium, which of course they've not yet finalized. So there is no standard presently which exists on BMS anywhere in the world. So we thought we'll take this initiative because we are in India. There's a lot of emphasis on renewables, and because of renewables, energy storage as well as electric vehicles, and battery is common to both stationary storage as well as in e-mobility. So this standard has already come out, and we try to now make people aware of this. Maybe we didn't have so much of a reach when we took out held this webinar, I think in December 2020. But we will keep on holding webinars for especially on standards of relevance, which are relevant to the industry, to people who use it. So the standard is already taken out. I don't know how many people know about this. We've not taken a survey on that, but it's already there. It's on the website of BIS. Yeah.
Yep. Thanks for this. In terms of and I'm in the second panel, I'm going to talk about this because we have a lot more industry practitioners, users there, and we'll talk about the standards. But Mani, from your perspective, when you're designing or when you're talking with your battery pack suppliers, right? What are the top two or three things that you're looking after?
Yeah, safety is the highest thing, definitely. So I would also look at how how much the usable capacity I get out of the battery. Yeah, that is very important for me. And thirdly, the life, as a OEM. So what is the life of the battery, usable capacity, and my discharge capability. Now, how much is the maximum discharge I can have, so that how I can use it for my own performance outputs. So these are the three essential things to be, I would look at. I mean, there are other things beyond that also, but when you say top three, I would say this is the top three.
Perfect.
Yeah.
We are coming to close of this session. So, but I will like to invite some comments from Praveen in terms of how do you see this industry evolving? Yeah, the needs of the customer evolving, and then probably a same question to Manish.
So we have discussed that how the BMS is related to safety, but one important thing we are missing, very important information you shared, that how we are not paying too much attention on the temperature control in the battery. And recently we saw that in Delhi, one of the subsidy for one of the car model got suspended by the Delhi government due to the range issue. And because the company promised a particular range, but the customer was not getting that range. So recently we were trying to analyze that what is the reason and how we can create an awareness around that. What we found that when you are maintaining a battery temperature around 21 degrees centigrade, then you can get a optimal range from your vehicle. And the speed should be in the range of 30 to 35 kilometers per hour. So if you're not maintaining the proper battery temperature, then what will happen that the range anxiety will become a bigger issue, because already this is one of the issue in the customer's mind when they are going for buying the electric vehicles. So basically, we are going to create more uncomfortable situation in consumer's mind if you are not addressing this temperature issue. So for that, of course, we need to implement this very robust battery management system for consumer point of view as well as from the safety. And as you mentioned that two-wheelers is the major issue, and two-wheeler is going to have a big share in the total vehicle mix, even in the EV space. So of course, this issue of that battery management we need to take very seriously, and here industry can play a bigger role. That's why we think, like we talk about the plug-in versus battery swapping. So battery swapping, we get one additional advantage of very fast refueling time. Another thing that you can charge your battery in a very controlled temperature environment. So that can help you in improving the life of your battery. Yeah, so I think this is a very important thing, and if you're looking from the both the business model as well as from the consumer perspective, this becomes a very important.
Absolutely fantastic. Yeah. Just an aside on your views around battery swapping, and as a specialist in battery swapping, if you do an economic analysis of cooling batteries, charging batteries in a cooled environment versus the life degradation that you get by not charging batteries in a cooled environment, to the best of my knowledge, it doesn't make economic sense to charge batteries in a air conditioned environment. Yeah, so that's just fallacy of India. Yeah, that's just reality of India. Yeah, so that our ambient temperature generally is 40, cooling something from 40 to 20 degrees Celsius. The amount of energy that you require per capita battery is, and the cost that you incur for that, in most of the cases, it doesn't compensate for the degradation of the battery. Yeah, it's just from my own experience. Yeah. So Manish, what are your views on this?
You're absolutely correct. After today's discussion, and the one takeaway I would like to people should get it from there. When we talk about a BMS, it's not off-the-shelf component that people should look at BMS not as off-the-shelf component that you can just simply go in the market, buy it, and put it on a vehicle. People should understand the technology behind it, that how it should be mated with the battery pack. As you correctly said, that some of the data will have to come from the cell manufacturer. So it has to be tightly integrated with the battery pack. Then only the safety and the reliability issues will be handled. And I think people themselves should be more technology aware in this area.
Perfect. Milind, any last words from you?
Yeah, what we are talking about the cells, and when it comes to BMS, it's like a human being where we want to keep it in all control atmosphere, take care of it, and BMS is the only way we can handle all this irregularities which is coming in on the cell point of view, like the temperature, high temperature, voltage over discharge, short circuiting. So this all and then comes the diagnosis of it. Means it's not only the measurement of it, that then how these parameters will be measured and how any error happen in that thing, how that can be taken care and how it can be reported to the end customers. These all functions can only be done by the BMS. So as a integral part of any tech, BMS has to have all these features, and it's needly to say that we can get away with the BMS requirement.
Perfect. So I think thanks. I would like to thank everyone for their views. It has been a good discussion. Geeta, over to you.
Mr. Piyush, I'll just request you to take a few questions since we have time, and we have the panelists with us. So probably a few questions from the Q&A box.
And you would be doing the selection, or shall I do this?
No, sir, you do the relevant questions. You would be knowing the relevant questions.
Okay, perfect. Okay, so I think the first question there is from the gentleman Naveen Andanur, and Manik is, I think, trying to answer it, but we'll open it for everyone. Does BMS ensure that each cell is uniform in its thermal behavior? If yes, how is it managed? Mani, you would like to take that?
This is what is the basic functions of BMS, right? We have cell balancing. In balancing, what you do is we uniform. See, there are two things we say do that. One is the selection of the BMS itself, cell itself. We sort the while doing the manufacturing, we'll sort the cells so that the characteristics become uniform. It comes from the same page and same impedance value, which is started together. And secondly, we also make sure that using the BMS, we do cell balancing. There are two types of balancing, passive and active balancing. So make sure that each cell is uniformly charged. Is that the answer? I mean, any other, what was the question? So sorry. Does it answer?
Yes, it does. It does. It does. It does. Yeah. Well, there is one more question that we'd like to take. It's a very similar question. Does BMS control every single cell in the battery pack? This is coming in from Mahesh Chandra.
BMS does not control. BMS only monitors. Yeah, of course, the controlling is where it is controls is, suppose if it's activating a contactor in situation where something going drastically wrong, or it controls the switching, for example, charging and discharging. So these are the two control mechanisms. Other than that, it is only a monitoring and ensures the safety and ensures the balancing of charging and discharging.
Yeah, and then there is a follow-up question. Do we have different BMSs for different regions like cold places and hot places? Manish, would you like to take that?
Yeah, Manish, I think you're the right person probably.
No, we cannot have a different BMS for different region, but yes, that is a problem in especially our country where there is so much geographical variations. So again, it has to be a combine, as Manikanda sir has been saying, it has to be taken at a system level, the cell selection, the battery pack engineering, and the BMS, all the sensors, all the circuitry required. So it will be a combined system effort to make a system that is that will work in all the regions. So we can't have a system, different system working in a different area. That will never work in field, and it will not be viable for any manufacturer to have this.
Yeah.
Perfect. And can I take one last question? So I think this is more of a generic question, but this will actually give us a good idea about the state of industry in India. The first part of the question is, do we import hardware components of BMS like safety circuit? If yes, from which countries? Anyone wants to take that, or I can take that answer?
For you only, Phil.
Yeah. So we don't make any BMSs in India. 99.99% of BMSs are imported from Shenzhen. So we don't import components for BMS. We just import BMSs.
But yeah, Piyush, you could make some changes here.
Yeah,
in the market.
We are trying, right? So, but again,
is it cheaper to import it than to manufacture it in India?
No, Pankaj, I would like to answer that, and and allow me a couple of minutes to answer that. Based on my previous experience, I ran Tyco Electronics, and I ran plants both in Shanghai as well as in Bangalore. My Bangalore plant was cheaper than my Shanghai plant. Same standard, same global standards.
Yeah. And why would you do that?
So again, the reason India is importing a lot of stuff from China is because it takes significant amount of time to develop a product and perfect the supply chain, right? And again, someone needs to support it during the time when the stabilization of the supply chain happens, the stabilization of the design happens, right? Fortunately or unfortunately, neither the Indian ecosystem nor the Indian government has supported any kind of R&D within the country. Whereas the same thing has been supported very heavily in China. Yeah. So in my previous in my previous company, when I was leading that company, and it was an American company, my entire R&D was paid by the Chinese government for an American company. Yeah. So that's the difference. Yeah. But the sad reality is everything is imported by the tons. Yep. And just to put things in perspective, it has absolutely no sense of what the temperature conditions for India.
It's even worse.
Yep. So that's just our perspective of this.
But yeah, this one point, one more interesting thing which I want to touch upon. Somebody asked about the temperature level. See, when we build this, let's say when we build these control systems, we build an operating temperature varying from -40 to plus 125 degrees in the automotive application. Because I come from a tier 1 supplier where we make these components. But it is also not necessary for India, because India, the temperature never goes at -20 or -40, right? So that means sometimes we are doing over engineering. We are buying an over engineering component in India, right? This is not necessary. We can bring down the cost. Even for a cell also, why do we need to have a cell which is working -40 degrees in India? So that means you are paying more. When you want to make this component work on minus levels, you have to do more engineering and more cost actually, which can be optimized when we do things in India, for sure.
Yeah. So I think the key message is largely around it's a very nascent industry. I think there is a lot of development that has happened, and a lot of education that people have taken over the last 3-4 years that I've been associated with this industry. Right. So I think in late 2017, the discussion with people was, what is an electric vehicle? What is a lithium-ion battery? Yeah. So the discussion has now shifted from what is an EV, and we're talking about safety in an EV right now. Yeah. So that's a fantastic change. Yeah. That's how the industry evolves, right? So and we probably would be on a very similar path for the next few years. Yeah. So it looks pretty interesting. Yeah, I think we are all progressing in the right direction. It's just the pace is a bit slow, specifically in terms of developing some indigenous solutions.
If you have standards in India on various issues of maybe BMS and others, do you think it gives opportunity for people to start developing it in India, or still it's because of the supply chain problems? I think
I think the biggest thing is around compliance. We can have fantastic standards, but if there is no compliance,
okay,
right? We have fantastic standards around cells. Yeah, but I'm absolutely certain every practitioner on this call or on this session would agree. The compliance with the BIS standards on cells is probably something that can be significantly improved. Standards are good. The compliance is a key.
Thank you.
Yeah. Okay. Perfect. Over to you, Geeta.
Thank you so much, all the panelists, for this very, very insightful session, and Mr. Piyush for a wonderful preparation of this session. Hope there's a lot to take away for our attendees from this discussion. And now, before moving on to the next discussion session, we will be having a very important presentation on fire suppression of lithium batteries used for EV applications by Mr. Sashi Sargai, Commercial Director, Epitous Group of Companies. Nowadays, the lithium battery fires are the real concern, as the number of devices and especially electrical vehicles is growing. And as I have already mentioned earlier, Epitous is one of the main designers and producers of firefighting equipment with more than 25 years of experience. So I welcome Mr. Sargai on the screen. The screen is all yours.
Hello. Okay. Hello, dear participants. Thank you very much for the introduction. My name is Sergey. I'm the commercial director, and I'm leading the project of the fire suppression of lithium-ion with the world with the companies. I will give you a quick overview who we are. We are the 30 years old company this year, and here are the main our clients that are presented. There are some people and companies from India which we gave our expertise to, and there are big Russian manufacturers and infrastructural partners that we supply our systems and means for the electrical transportation. And talking about our topic, even though the fires on the EVs are happening 9 times less nowadays than on the cars with internal combustion engine, it is still a growing concern as the number of EVs and electrical transportation is growing rapidly year by year. And here are some evident incidents that you might know, and the fires with lithium-ion batteries are really hard to extinguish. For example, a couple of years ago, there was an incident on the show of Grand Tour when the Richard Hammond, the presenter, crashed on the rimac down the hill on this electrical supercar, and it was catching fire repeatedly, even though it was put into the water container. So it is a big safety concern. And also the transportation with the batteries is growing in all of the directions, from the personal transportation, small personal transportation like e-scooters, and to the big transportational infrastructures like e-buses. And if we take a look, what is the lithium-ion fire, how it is classified? First of all, the solid materials, it is A class fire. When the electrolyte is burning, it is like burning liquids, B class fire. And when the electrolyte evaporates and goes out from the cell body and starts to burn, it is the burning of the combustional gases. It is a C class fire. So from the theory overview and from our wide practice, some manufacturers of the cells, they classify these fires like burning metals, but this is not completely right from our point of view. And well, the main reason for the fire is the thermal runaway, which can happen due to various reasons, like damages, like insufficient cooling, like over discharge, overcharge, or a car accident. And the cell that has gone to the thermal runaway cannot be stopped, and of course it can lead to an explosion, chemical emissions of toxic gases, and the fire, of course. And due to some research on this following graph, you can see that the best mean for the lithium-ion fire, it is the water. However, other means can also be used, because they also can extinguish the fire, but they're not as effective because they don't cool down the batteries. And the safety cost of the whole transportation is estimated at the level 1 to 2% of the end cost of the, and even though it is well, from the overview, it is a sufficient part, but there are problems happening, and the most evident problems when they can be estimated, it is like the drop of the share prices when the accidents happened, and of course it can be treated. It is just like a reaction of the society. It is loss of the customer trust, loss of the share price, and the decrease of electrical transportational reputation. And when we started to explore this problem, and we found the first solution, it is the aerosol, fast, environmentally friendly and reliable technology which can be fully autonomous. And the second, more recent solution, which has finished the fire test just this summer foam, the special compound which sticks to the surface and isolates the fire. And the first fire tests we did with aerosol, and we took the widely used LFP cell manufactured by Epitous 3 Systems, which has found wide application in electrical vehicles. And we extinguished the fire with the aerosol. On the graph you can see on the right, and extinguishing took around 15 seconds, but this means they have some limitations, that the aerosol generator should be as close as possible to the place of the fire, to the battery, and the volume, where it is installed, should be sealed or conditionally sealed, so the aerosol don't go away. And these tests were done in the pre-COVID time, and our partners all over the world already started to use that in the manufacturing, transportation of transportational applications at the container energy stores. And the solution was the fast above the other cell to the thermal runaway, and suppress the fire just in 5 seconds. So the second battery that was beneath didn't go to the thermal runaway, and so there was no this chain reaction. And safety rises sales and also saves money. Of course, it is a wider look, not just a fire safety, but according to the researchers, for example, the car that get 5-star ratings for safety, they are sold better, their sales grow, and the vehicles per kilometer traveled is grow, and the killed or seriously injured people, this number decreases. And about our current work with the e-transport, we equip almost all the buses that are supplied in Russia, and all buses, electronic buses that are, for example, this is the KAMAZ one. And here you can see how the system looks. On the left is the control panel, and on the right, these are the fire extinguishing means. And also we protect the whole underground metro of Moscow and Russia since 1995. And the next generation that will come already with lithium-ion batteries, this will be already also equipped with our systems. So for now, there are two solutions for the e-transportation. First is affordable and autonomous small solution, which can be installed right in the battery pack. Is the aerosol, or the more effective for the big fires, but it is needed application in the bigger objects like the buses, the trams, even the electrical ships. It is the fast hardening foam, so it's like a tailor-made solution for the transportation where the weight and dimensions are not that important and not that crucial. That was all. Thank you very much for your time and attention, and let's make tomorrow transportation safer today. And now I'm ready to answer your questions. I will take a look.
Yeah, from the Q&A box. Can we see the questions from the Q&A box?
Yes, yes.
Mr. Seki, are you able to see the Q&A box?
Yes, I'm looking for the relevant questions. Yeah.
If you cannot find a relevant question,
So
I'll just say that, are you able to pinpoint?
Yeah, I think I found from Naveen, so can the coolant which is used follow the thermal management? No. Well, can this coolant used as the fire extinguisher? Well, that's possible, and in the beginning of the Epitous, we were trying to get the cooling system liquids to extinguish the fires under the hood. However, it is way more expensive because you have to have a pump and the proper sprayer and some kind of the better detection to use this. So if there is an accident happening and, for example, all the fluids go away, there will be nothing to extinguish the fire. Can a better installation be a solution to avoid fire cases by Mitesh? Well, I know that manufacturers already use the advanced materials that are certified and approved by big laboratories. However, the cases are still there. Probably yes, but this also, you can never exclude the possibility. How much cost effective is your fire system? Well, the smallest solution for the battery pack is starts from like 45 euros, and it is installing just on 3 bolts right in the battery pack, and serves for 10 years without any maintenance. Is there anything for battery fires? Well, this for by Nischay. Yeah, this was, I was talking about this. Our means, they are designed to extinguish the batteries. How can we identify ABC class fire on a practical visualization and take a preventive action rapidly? So, well, this identify it visibly from the battery. This is
Yeah, Mr. Sege?
And what kind of solution have you provided to Ashok Leyland? I told that this is the companies that we gave our expertise to, and the personnel from this company visited our webinars. And as far as we have 2 distributors in India, I cannot in detail show now if they supplied something to them or not. I just know that though this company was visiting us and get some expertise from us.
Ms. Sege, sorry to interrupt in between. I think we should start over with our second panel. And we do have a lot of questions in here, which could be just taken offline, or you could just answer it over the chat. I think all the answers will be there in the chat.
Okay, thank you very much. Okay.
Thank you. Thank you so much, Mr. Sege, for this wonderful presentation, and a very interesting presentation indeed out there. So now we are at our second and last part of our event, where the panel will discuss about the most important technologies in the battery management system of electric vehicle application. And for this, we have in our panel Mr. Shankar Akela, GM EV and E-Mobility Solutions, Ashok Leyland, Mr. Piyush Gupta, founder and CEO, Lithium Power Private Limited. He is also our session moderator. Mr. Avinash Kale, Director and Head of OEM Business Development and Application Engineering, Automotive Infineon Technologies Private Limited. Mr. Shashi Sargai, Commercial Director, Epitous Group of Companies. Mr. Saurabh Kumar, Founder and CEO, Euler Motors. Mr. Nagesh Shrikant, Head R&D, Hero Electric Private Limited, Hero Electric Vehicles Private Limited. Mr. Dheeraj Chaurasia, Head Vehicle Integration R&D, Tork Motors. Now, may I just hand over the session to Mr. Piyush to take the charge again. Mr. Piyush?
Thanks, thanks, Geeta. Okay, perfect. Thanks for the second session and welcome everyone again. Let me just start off again with a very quick introduction from the panelists. May I invite Shankar, if you could just give a brief introduction about yourself, your interests, and the organization that you're representing.
Thank you. Good afternoon, everyone, and it's a pleasure to be here in this panel discussion. I am coming from Ashok Leyland, and my basic interests are in control algorithms. I have worked in my career on all the new technologies like fuel cells, batteries, electric vehicles, and autonomous controls in all the controller area. Currently, I'm heading the controllers and new technologies within Ashok Leyland. Yes, can you hear me?
Yeah, sure.
Oh, sorry. Currently, I'm heading the new technologies and control algorithms team in the e-mobility division of Ashok Leyland.
Fantastic. Welcome, Shankar. Can I then request Mr. Avinash Kale?
Yeah, good afternoon all. My name is Avinash Kale and basically heading the system application engineering activities and OEM business development activities at Infineon India. And I'm based out of Pune, basically with Infineon for more than 3 years now. And for most of my career, I've been basically dealing with embedded systems, electronics, and semiconductors. So nice to be here, and I really look forward to a nice interactive panel discussions and learn from other panelists as well. Thank you.
Thanks. Can I now invite Dheeraj?
Yeah, am I audible?
Yes.
Yeah, thanks, Piyush, and thanks for calling me up here. Good afternoon, everyone. So I'm currently heading the integration department at Tork, experienced with individual part or component level development, majorly used in electric vehicle. That includes electronics control unit, BTMS, and the DC instrument cluster. So been part of development team across the components.
Good to have you here. Can I now request Saurabh?
Hey, hi, I'm Saurabh, founder and CEO of Euler Motors. We have been working in the light electric commercial vehicle segment over the last 3 years. Happy to share my views, learn from everyone. Thanks for having me on this panel.
Nagesh?
Yeah, hi, good afternoon, everyone. This is Nagesh here. I work at Hero Electric Vehicles Limited. I am responsible for R&D activities on the electrical and electronic side, dealing mainly with batteries, motors, and all the control unit development. Happy to be here and share thoughts, learn, and discuss with all of you.
And while we have heard from Mr. Sergey, can I just request him to give his introduction again for people who just joined in?
Yeah, hello. I'm Sergey, the commercial director of Epitous Group, and leading the project of fire suppression of lithium-ion batteries worldwide from Epitous Group, and happy to be here.
Thanks everyone for the introduction. I'd just like to start off this discussion with a very simple question, right? So, can a simple stuff such as BMS turn a vehicle into an intelligent platform? Yeah, different views. Can we just start off with Dheeraj and then move on to others?
Yeah, definitely. So I think we discussed a lot on the BMS, talking about how intelligent it can be. This requires certain knowledge and understanding before we go on further development, like we discussed earlier also. Some parameters, like we discussed, understanding of the cell chemistry. I mean, the composition, chemical reactions, the density it is containing, and the performance characteristic that also we discussed. That's very important. That includes the understanding of the chemistry, charge, discharge, temperature, and impedance characteristics. That's basically supplied with the manufacturer, including the battery failure modes, like the aging, the abuse, and the development that includes hardware as well as software, the algorithm basically that runs into the design that you are going to have. Also, understanding of the lithium battery failures that we already have discussed, and that is a basic requirement to be understood, like under voltage, over voltage, temperature, over temperature, under temperature, SOC, SOH, and manufacturing, including manufacturing defects and the damages that can have and that may lead to certain extent. And also the communication type the BMS is actually having, since it is it should be smart enough to talk with the other components so that it will be in sync. The intelligence basically lies there when it is compatible with every system it is onboarded with, so that it can sync and coordinate and function based on the requirements. So I think these are the basic understanding that has to be there before we start even with the design of the BMS. Once we start while making it intelligent, once we start further, we deep dive into the protection measures on cell level, and the controls on charge and discharge, and the demand over the management over the demands. uh, we also need some sort of authentication and identification that can actually safeguard on the that can limit basically the use of the batteries on the particular application, and also consider the necessary protection that has been already defined with the configuration onto that. Basic parameters also includes understanding of the SOH that we already have discussed, SOC, and the balancing technologies, and communication again is important parameter that has to be considered. So I think mostly we discuss on the smart, again, efficiency comes into picture, and the delivery to what is required, we say that can be defined based on the application requirement. It is either electric vehicle segment or the power management segment on the grid side. So basically, we discussed on many parameters that actually help BMS to work or function on the given operating conditions that makes it reliable and safe in nature. So I also like to include something that is very important, including all those factors, is uh, the analytics, the telematics right now is a trend in technologies where we are capturing much more information, historical data from the cells or on the battery pack level, where we can have certain analytics on how it has been performing. That can be used uh, uh, with the lookup table that basically a cell manufacturer used to supply us, or we can experience it and match it with the lookup table that already manufacturer has supplied with us, and then finally we can have our own algorithm that manages things between both and gives us the optimum output, considering the safety and reliability of the packs. So basic parameters lies on SOC, SOH. That is more important, and it is interdependent parameter of voltage, current, temperature. That so far we have been discussing here. So I feel these are the necessary parameters that makes the battery intelligent to be considered.
Thanks, Dheeraj. So Nagesh, if I can get you in the same debate, what are your views around and how you are utilizing the intelligence?
Yeah, Piyush. So I think the way I would look at the smartness or intelligence of the battery management is directly linked to what the application we are using it in. So, I mean, at its heart, a BMS is essentially there to protect the cells, and therefore needs to monitor and observe the current voltage and temperatures and ensure that the cell remains safe, and therefore the vehicle remains safe. And this can be accomplished very simply also with only hardware, and then cutoffs coming in and stopping the vehicle from getting into a troublesome zone and staying safe. Now, when we add a layer of software on top of it, then the smartness starts to come in. And this actually today there is no real boundary of what level of smartness we can bring in, because at the battery management level itself, so already like Dheeraj mentioned, things like SOC, SOH, even observing hysteresis based on use cases, because typically, at least in the two-wheeler areas, there is a clear retail use case and there is a commercial use case. And in those cases, the batteries are not always driven the same way. So how can the batteries understand this changing charging and discharging profiles and then still manage to deliver consistently? This is some part of the intelligence the software will bring in. So, and again, the safety requirements are different. And typically, we could also look at the cells which are being used. And there are some relatively more stable chemistries, in which case the software layers need not have too much complication. You could also, from a safety point, be sufficient maybe with just an ASIL A or a ASIL B kind of development, whereas on the software at least. Whereas with more more exothermic reactions in some of the chemistries, you will need to be a little more careful on what kind of software is there and what level of redundancies and safety features are there. So I think the intelligence or smartness will depend on the application. So when we have got vehicles where historically we have come from a lead acid kind of battery background, and the applications are in relatively safe environments, probably you could have more simpler software which still is safe without adding all the other additional features which could help you to cater to things like range anxiety. How accurate can I make my SOC, and therefore how much more accurate will my distance to empty prediction be? So I think these are all the intelligence we could keep adding in also on the application side that will add more value to the product, and therefore also on the higher segment on the pricing. So this is how I see this picture on the BMS. There's a broad range here also, while the product is still the same as a BMS.
Perfect. Thanks. Thanks for your view. It's good to see good congruence between what Dheeraj said and what Nagesh said, right? So, sort of getting you on the same debate. Is there added value that you see from getting the data out of the BMS, and how are you utilizing it?
Oh, thanks. I think I agree with Dheeraj and Nagesh. The only point that I wanted to add, and I think that I think the topic point which you spoke about was smart BMS turning EV battery intelligent. I think the one of the fundamental thing that we felt that an electric vehicle require in India, looking at the diverse sort of weather and temperature and requirements, and even the load requirements that we saw in the vehicle, being ability to change configuration depending on the kind of condition vehicle is in. And often than not, we wanted to have an ability to, let's just say, have an OTA where we can do an over-the-air update. For instance, if the vehicle is, let's just say, operating in Kashmir versus operating in summers of Delhi, having different sort of cutoffs to give us different kind of range. I think that could potentially one area where we felt that an battery can adapt to different weather condition, different temperature condition, different load condition, and can still deliver the kind of range and life that we require. So yeah, that was one point that I wanted to add over everything like that was mentioned.
Thanks, Saurabh. Let me just shift gears a bit, and I would like to speak a bit more about the, how is the technology evolving in this, right? So there are two parts to this. Are we able to, get some newer technologies in the BMS? So there is a lot of talk about, wireless BMSs, wireless sensing. Can I request Avinash to, to bring his views on that, and maybe Shankar, if you have some views on that after that.
Sure. Thanks, Piyush.
We'll start off with Avinash here.
Thanks, Piyush. Yeah, I mean, this is the latest topic in discussion. Yeah, many people are discussing, and there were news like some OEMs are coming with the the wireless BMS in this case. So if you want to understand what is real difference between wired and wireless, right? Let me just go back to the statement here that when you have complete battery pack, the battery pack, if you open the battery pack, what it has basically it consists of different modules, right? Different battery modules, and the battery, each and every battery module has number of cells in parallel and series depending on what voltage the system has and what current requirement the system has. Now, when you talk about wired BMS, what essentially you have is each of these battery modules is connected to the other battery module with a pair of twisted cable for the communication. So that's how the data propagates from one module to the other. And in the end, one of the let's say the bottommost or topmost module is connected to the host controller for then taking this data and doing SOC, SOH, etc., in this case. So this is all wired in this case. The topologies in the industry are typically daisy chaining or even ring topology, to be able to traverse to any node in between or any module in between. Now, when you talk about wireless, what is the difference? All these twisted pair, wires, along with the associated circuitry, are being replaced by wireless technology. And when we say wireless technology, either it can be Wi-Fi, it can be Bluetooth low energy, or it can be any other wireless technology or interface for that matter. Now, what are the factors really? What to choose? And this is, let's say, from my perspective, there are a few key parameters which you should keep in mind while selecting to go for wired or wireless. Some of them like cost, weight of the system, space available in the vehicle, then reliability, safety, and security. These are key factors you should consider before going, deciding on which technology to choose for. Now, when you talk about some of these, cell module controllers, we call it as, or some people call it as cell supervisory circuits. Some people call it as, analog front end sensing IC or BMS IC. Some of these SOCs do require a lot of isolation components, as in the form of common chokes and etc. And these are quite bulky and expensive at times. And there comes the need of, let's say, there is the necessity or need of the wireless system in that case. But if you ask me, is it really necessary? I would say no. It is because in the end, what you are looking at is the cost difference. In this case, there are some CMCs available in the market, and we have one like it, wherein we don't need any common mode chokes or any bulky isolated components. The communication only happens over two simple twisted pair cable with capacitively coupled. That's it. So you have 4 capacitors, simple capacitors, and 2 wires on either side of the module. That's it, nothing more than that. So that is one aspect. Second aspect is about the reliability. And as we all know, wired is always reliable. Right? I think there is no discussion or doubt about it, right, in this case. Now, when it comes to safety and security, I think security also is a key element in here. And we all know that, the content environment is more secure. So that means the wired is more secure, whereas wireless is prone to, more threats, and it's more vulnerable as a system in that case. So in nutshell, if you ask me, what to choose, my take on it, some of the select OEMs, so-called select OEMs, might go for wireless for their high-end, high power, premier segment, but rest all the segments, I would see that I would definitely see that the wired will be more prevalent BMS system as in general.
So thanks for clarifying that the wireless part is not the sense wires have not been replaced. After this news report came in, there were a number of my customers who said, now I want to remove my sense wires. Yeah,
exactly. So people always look for fancy things, right? That's where the things come. And then some companies which have vested interest, they will definitely go for no wireless in that case. But I think there are some parameters which you should really assess and decide whether you really want to go for wireless or not. I think that's the key here.
Yeah. So again, just to clarify for all the viewers, it's the wireless part of the BMS is not to remove the sense wires from the cell to the BMS. It is essentially the BMS communication removes the RS-485, the GAN protocols, and makes it into more of a wireless communication from a master-slave perspective, nothing else.
Yes.
Yeah.
Exactly.
So that was fake news a couple of months ago. So we moved away from the fake news. Thanks for clarifying, Avinash. Shankar, your views. So you are, there are two types of applications in the market. You have light applications, and then you have heavy, and then you have buses, right? So what are your views on the real heavy applications?
I think probably I want to add to what Mr. Avinash mentioned about the new technologies. So I agree with whatever he mentioned about wireless and wired communications. Apart from this, especially though I'm coming from heavy duty vehicles, but there is a new technology which is coming up, which is more suitable for the two-wheelers and maybe three-wheelers and also maybe cars. So that is a reconfigurable BMS. So as Mr. Avinash mentioned today just now, the configuration of the thing is you have a module, you have a pack, inside the pack you have cells, pack, module, and cells. That's the sequence. But in the reconfigurable BMS, you only have cells. All the cells are connected to a big, what do you call a PCB, which kind of dynamically switches and gets you what combination you want, series and parallel combination you want. So the major advantages of this technology is if you crack it correctly, you can get away with onboard charger, and also you can get away with a traction inverter, which is required for this thing. So one BMS and the pack alone can be sufficient to cover things. And there are a couple of companies I know who are working on this. So probably if people are interested, they can connect to me and I can provide that information. That is some new technology which I'm very excited when I saw that thing. But right now, whatever the prototypes they have, they are only for smaller vehicles, and we don't have anything for the bigger vehicles like buses and trucks. Coming to the buses.
So Shankar, just to get a clarification on that, so this newer technology is about changing the parameters at a cell level.
Not the parameters. Basically, you have the sense wires and also the power carrying wires. So all this goes to a common PCB. And in the PCB, you have a switches, which kind of switches dynamically based on your BMS inputs and provides you the output current. And the measurements will be same. The sense wires will go to the BMS as a regular process. But only thing is, instead of going to the power lines, which are going to a common bus today, they will not go directly to a common bus. It will go to a switching network, and the switching network kind of switches depending on what configuration you want. And so if you want a sine wave output from the DC, it can get it. That is the advantage. By just switching the switches appropriately, they can get it. And you can change from a series of 4 to a series of 2, like that. You can change it dynamically. So that is what is called a reconfigurable architecture. And so there are a lot of academic research is going on, and also there are a couple of companies who came up with the prototypes for these reconfigurable architecture-based battery packs and BMS solutions.
Fantastic. Sorry, you're talking about the buses when I interjected.
Yes. So buses, I think, there is a lot of, as you rightly mentioned in the previous talk, both buses and cars, there is more design went into the battery management systems and also the battery packs and the whole vehicle. Mainly, there are reasons are legislative and regulatory requirements are already there. And apart from that, safety aspects are also very critical, and all the companies are worried if any incident happens, it's going to impact their brand. So that's the reason why these are, I would say, more engineered than a two-wheeler BMS or thing. And coming to these commercial vehicles, they have a different requirements. For example, if you look at the commercial vehicles, buses, they operate almost like 200, 250 kilometers per day, or 15 to 15 hours per day they operate. And they would like a lifetime of 10 years, which will give you around 10 lakh kilometers, something like that. So the requirements here are kind of very different from two-wheelers and cars, passenger cars. And because of that, they pose some complex requirements on the battery management system. And so some of the things like which you mentioned earlier about the safety, and also some things like the measurements, temperature sensing you are saying, these are all standard in our battery packs, car battery packs, I mean car and also the commercial vehicle battery packs. And that's what I want to say. If you need any, I mean, if you have some more details, let us take it in the next round. That's what I would like to say.
Thanks. So the other part that I wanted to touch base slightly about was, and this is what Saurav has mentioned earlier, is around the thermal management. Yeah. So Saurav, I know you feel a lot about the thermal management, and Shankar, you were talking about thermal management. So what are your views around it, and how are you tackling this, Saurav?
I think especially for the commercial vehicles like buses and trucks, I would say in Indian climatic conditions, you have to have a liquid cooling or some kind of active cooling is required. Without the cooling, it is very difficult to operate the buses or battery packs safely. And so that's the reason in almost all the vehicles what we have today, we have a liquid cooling in place, and we do cool the batteries during charging and also during driving, all the battery packs.
Saurav, you also wanted to share some views on the same?
Yeah, so the way we look at battery thermal management system, there are like 4 things that actually we think about. Mainly which kind of impacts 2 high-level topics, basically your operational and sort of economic impact. But essentially the 4 things that we think about is the range, life, and then charging time, and any kind of cutoffs that could happen. And these 4 things, I'll just explain how battery thermal management system kind of protects or improves. So let's just say if your batteries are at in summer condition, let's just say we are in Delhi at 45, your battery is going up to 55 degrees, could potentially lower your overall range of the vehicle by 10 to 15%, versus like scenarios where if your ambient was, let's just say, around 25-30 degrees. So that's a one range impact. The second one around your life cycle. Let's just say if you're operating your batteries at 0 degrees or 5 degrees in winters that we have seen in your northern part of India, very early morning when you're trying to charge the vehicle overnight. In those conditions, if let's just say if you're plugging in your battery packs at early sort of like lower than 0, sub-zeros, and you're charging, it will impact the overall life. And obviously with higher temperature also your range does get impacted, but we have seen charging below 0 like impacts it like heavily. The third thing that we have seen the impacts around thermal was your operational cutoffs. So let's just say to protect your battery pack, you have limited batteries to not go above, let's just say 50-55 degrees to avoid thermal runaway challenges, which I think Sergey talked about earlier. In those situations where if you don't have thermal management, you will have issues where because your BMS is controlling the overall flow of current out of battery pack, it will shut down the battery pack. In those conditions, your vehicle will stop. You will potentially probably stop for 5-10 minutes for letting the battery to cool down, and you will start operating again. You can increase the temperatures, higher temperature, allowable temperatures to 60 degrees in some of the scenarios, but it will still lead to like, either you are letting your life go or your overall, you're increasing the risks. The fourth thing that we saw that, that was getting impacted was your charging time. It takes longer to charge the battery pack if your battery packs are heated. If you're, let's just say, charging batteries at 25 degrees versus if you're charging batteries at 45 degrees, your cell's ability to take more and more current. You can push more current, temperatures will again further rise. So typically your the way your BMS charging codes or charger codes are written, typically to limit the current as your temperature rises. So these four things, right? Fundamentally, your range, life cycle, your overall operationally cutoffs that are going to happen, which limits the vehicle experience, driving experience, and the fourth thing around your charging time. To solve for this, I think an effective thermal management is required, and that's where, like, we believe that, like, as India is going through this phase of better and better EVs that are going to get introduced, technology will further improve. BTMS, I think, will become one of the center topic of discussion, and this essentially, these four things links to your operational and economic sort of benefits, in the sense, if your vehicle drives for lesser period of time in a day, or it takes longer to charge, or it degrades faster than what it should have had, you essentially have lower secondary value, or you have not yet still paid the EMI, or the financier cannot take the risk of financing the vehicle for a longer period of time. So all this culminates to some kind of economic loss and financial loss. So that's where, as Euler, I think we were always, I've been proponent of thermal management, and I think liquid cooling from the very early days, and we have built liquid cooling solutions for even the three-wheeler battery packs, where we have seen in cargo applications your current that are often required to drive like 1 ton or 700 kg of cargo loads are very, very high. And to give that kind of 4 to 5 year life, you need like a very effective thermal management system. So yeah, that's mostly like my view on BTMS.
Perfect. Thanks, Saurabh, for your views. I think we're coming to the end of this, but there's something that I would like to just ask the entire panelists in terms of we have people from different OEMs and users here, right? So how do you ensure the quality of BMS coming into your battery packs? Is that something that you guys specifically take into account? So maybe that's something that we can start off with Nagesh, then over to Dheeraj, and then back to Mani, if he can still come in, and then to Saurabh.
So
yeah,
typically,
Nagesh.
Please. So from a point of view of the quality of the BMS, there is the design quality on the one side, in terms of what is the product designed to work for. So that is a clear part which is always under control from R&D and engineering side. Then there's the other part of the manufacturing or production quality, and therefore the incoming quality checks that are done on the battery packs. I think these are the two critical parts of what we do in terms of quality. First of all, a quality product development, and then a quality on the manufacturing side, so that we have at our vehicles everything working as required when we have assembled them into the battery packs and eventually into our scooters.
So, sir, let me ask you a different question on this, right? So the question is, do you buy a battery pack, or do you buy cells and BMS separately and get someone to make battery pack for you?
So in our specific case, we buy cells, we buy BMS, and then we assemble packs, and then assemble them onto the vehicle.
So that's how you ensure the quality.
Correct.
Okay. So Mani, if you can.
Yeah, sorry, I was a little bit better. So the case is very clear. See, when you have to say quality, as a product level, it is our responsibility to ensure the product level quality, right? Because finally, it goes with the customer, with our image. So that is we ensure that all the final testing assembly level, it's happening at our end. But otherwise, we leave to the battery manufacturer, because he knows what is the right kind of a BMS and right kind of the system. But we only define the requirements and specification very thoroughly and clearly. And from our end also, once it is comes to our premises, we'll thoroughly check, and we also clearly define the testing mechanisms and test procedures and what is expected out of the packs. We also have data points coming out from our customers, right? So all these customer inputs and quality inputs and the standard and the compliance and what is required. Basically, we define very clearly, and we ensure that that is taken care, by the pack manufacturer.
Perfect. Quick comments from both Dheeraj and Saurabh around that.
So it happens both way. Like if we start with cell selection, so mostly we get the cells from the market, and then before that we have function statement of function, what I stated last time, that is defined on the application level. What actually we what is the target for the application the BMS should have. Getting the cells, the characterization report from the manufacturer, also getting it tested with other labs to have certain fallback data, so that we can match it up with the manufacturer as well. Then after we go for the design, where we consider the necessary items that already I mentioned last time, that is related to the safety and reliability. Also, what I think Saurabh mentioned is OTA, one feature. That is something that is very important. So either you fix the parameters based on the battery that you have designed on the application side, or else the BMS should be flexible enough to cope up with the change in the arrangement of the cells or the pack or the capacity you want to derive it. So that also helps you a lot when at the time of commissioning the product, you can have some set of parameter control over the system. So this BMS can be adaptive to any of the combination of cells you are designing. Either it can be configured through wired or wireless communication, as mentioned by Bluetooth or Wi-Fi or anything, or else maybe like after some uses, you have some statistics and reports on the performance and other factors that can be fine-tuned based on the requirement of the product. So I think these all things are very much important to be considered to have the battery intelligent.
So just moving on to a slightly different topic. So I would like to get Avinash's view on what are the emerging technologies that could impact, the way we see BMS going forward. So Shankar had mentioned about a couple of those, the configurations. Then we spoke about the wireless one, which actually is a very different application layer. But from your perspective, Avinash, where do you see this technology going? So there are two parts to the technology. Either technology can get better or technology can get cheaper.
Yes. I think technology is always getting better for sure, because of the challenges, because of the opportunities we have now coming with the electrification trend as in total. So when you talk about BMS, right, we are talking about BMS extensively for now. But if you really decompose the BMS, what BMS has precisely are the three different blocks, and then some of the associated circuitry along with it. Let's say the first and foremost is the cell module controller, which is basically the main part which is controlling each and every cell, right? And what it does precisely, what we've been talking from some time now, it monitors the voltage, it monitors the temperature, it does balancing, whether it is active, passive, depending on the system. It gives you diagnostics, basically exhaustive diagnostics of the batteries, and their health, and then the communication to the host controller. And the host controller does the rest of the part of SOC, SOH, then the cooling system, the control of charging, discharging, then also communicating to the other electronic controllers, basically, whether it is inverter or VCU or any other ECU for that matter in that case. And the rest, and the third part is a disconnect. In the event of let's say abnormal situation, we need to isolate the battery pack from the even from the rest of the system as a whole, and that is very critical. And we see a lot of people are nowadays using very fast solid state disconnect switches. In the eventuality when you have this abnormal situation, you need to really cut off the battery from the rest of the circuitry. And sensing this situation is the key. You need to sense it ahead of time, right? We talked about temperature sensor. We also see in the industry that people are not only dependent on the temperature sensor, they also have pressure sensor built in the battery pack or the battery modules now. And what does it do? It basically gives you early warning of the thermal runaway. There is already a legislation in the US which is basically GTR 20, and it says that you should give an early warning to the passengers in a car, let's say, which should be 5 minutes at least before the fire happens or any accident happens in that case with the battery. And with this regulation, a lot of people are implementing different sensing mechanisms, and one way is to put pressure sensor or multiple pressure sensors in the battery module or battery pack as in whole, and which gives you early warning of this kind of thermal runaway in that case. And along with it, we also see that some people are also utilizing ferroelectric RAM. These are actually non-volatile memories like EEPROM, but are very fast. So before any accident happens, you really can capture the last minute diagnostics data and can then basically decode what happened, when there was a crash basically. So these are some of the things which people are even adding, in the BMS system to make it more intelligent, to make it more smart. Thanks, Piyush.
Thanks, Avinash. Thanks, Avinash. Thanks for your views. Shankar, one last word from you on any emerging technology.
I think one of the things which we are working heavily on the algorithm side. So there are some smart diagnostics algorithms that are available that are in research. One couple of things are just using the cell voltage and current and temperature measurements, predicting the thermal runaway ahead of time. And there are some people who are very successful and showed it in the lab scale that this can predict almost 1 day ahead of the thermal runaway. Something like this is what we are more interested, because this is what makes the BMS more intelligent and smart, because you can predict the safety incident way ahead, and that's very helpful both for the saving the people and also for the saving them in asset. You can take the action much earlier before that actually happens.
Perfect. Thanks, Shankar. I think we're coming to the close of this session, but one last word from Sergey, if you can, provide your views on how we can make battery packs safer, and how are you seeing this entire market emerging? Obviously you are vested in making battery packs safer, but how do you actually see the adoption from the customers?
Yeah, well, I think the battery management systems are very important, but you can never exclude the factor of the people and how they use the transportation. And we are working with the big infrastructures, and we see, even though the battery management systems and the transportational systems give some warning to the drivers or recommend some processes to do or how to charge, but people sometimes they don't follow, and it leads to the accident. So I think in the battery management system there should be like a lag for additional capacity to prevent the failures by the factor of the people. And of course, it was very interesting insight from Shankar that we didn't know that there is I didn't that can sense the thermal runaway a day before. So I think this is very important, because if you know where the fire will happen, you can prevent it and do some actions before, because it is always easier to stop it in the initial stage than to wait and deal with the consequences. So yeah, this is how I see, and of course, in the new generation of the transport, I think the battery management system and the fire safety system should go along to help one another if something fails.
Thanks, Agit. Thanks everyone on this panel. I really appreciate your time. Back to you, Geeta.
Mr. Piyush, I'll just request you to take a few questions from the audience.
Okay, so there is this question from Kumar Jayant, which is interesting. It says, Is there any consortium of EV OEMs wherein data is shared for collective research? Example in BMS. Linked to this question around is if you have data or real life performance of the BMS for two-wheelers. So can I request Shankar and Nagesh to answer these?
There is an SMEV actually.
Sorry?
SMEV, Society for Mobility, manufacturers of electric vehicles. And there is another society called ESA, Indian Energy Storage Alliance. And then Society for Smart Electric Mobility. There's one of the society I got founded by me. Society for Smart Electric Mobility, that is based out of Coimbatore, and we are running in Bangalore and Chennai. So we have a lot of information, and the knowledge base available. And please go through the websites and check. And this is good. I mean, not in particularly only about BMS, of course, generally about the e-mobility and electric development in India. A lot of exchanges happening. Please, refer to that.
So maybe Piyush linked part is while we have also SMEV, IESA, largely also on the vehicle side and a very general business overview also in these consortiums. There are also industry groups now on collaboratively working on common projects. I mean, for example, there is this Mycelio Studios, which is generally looking to have common projects worked across the industry so that there is no one person getting there, it's a group getting there together. So given this question is more inclined to the second part of saying, is there data available in terms of being able to do technical analysis and so on? I think looking at these kind of consortia which share technical data for discussion, I think is an interesting way forward also to advance the whole knowledge of the industry as a whole.
Perfect. So Shankar, any views from you from very different application?
Yeah, as far as I know, I think the data, whatever is available, is mostly at the cell level, and we don't share the data at the pack level, and even the cell level data is also not shared. But there are some public data exchanges where you can find the cell level data, which was generated by a lot of R&D organizations. But the pack level data, it's very tough to get it, and unfortunately, there is no publicly available pack level data.
In fact, from what I know, this data is the most valuable thing that many companies have, right? And they would almost never ever release this data. Yeah, it either points out to the flaws in their batteries, or it shows their technology that they have implemented. So that's a secret sauce, either the good way or the bad way. And to the best of my knowledge, no business guy will actually share that data.
Joining.
Yeah. One last question is from Shantakumar Ravichandran, and that's more of a comment. He said, why cell balancing is important? Why do people talk about cell balancing so much? And he's actually giving a very interesting point of view. He says, in a cell, at a cell level, in a CV mode, even when you're doing a 0.05 C charging, that means you are putting a 2 ampere floating current when you are doing in a CCCV mode. But the BMS, the balancing is only maximum 200 milliamperes. Yeah. So what's the use of balancing? Why do people actually talk about balancing so much? I think this is something we can start off with Mani and then go to Nagesh.
Yeah. See, what happens if is, I will ask the question the other way around. If you don't balance, what happens? Yeah. And what is the SOC that you get? The SOC is, it is you will not get the right SOC, the overall SOC, that the overall capacity at least the pack can provide. That is point number one. Point number two, if the cell is not balanced properly, then the cells which are having a low impedance will discharge faster, right? So then the other cells will keep on discharging slower. So what happens eventually? The overall the pack level, the SOH will get impacted, and DOD also will get impacted. So the better operations of these battery at the pack level, the balancing between the cells is very important, and that is how you kind of ensure that a certain amount of capacity usage and the SOH, for example.
So I think the question is largely it's a very interesting question.
Different. It is that is different.
The question is not why should there be balancing.
Okay.
Right?
Okay.
The question is, in an operational scenario, when you are charging at a very low level, even at a 2 ampere current, and you are balancing at 100 milliampere, it is meaningless. That is a question that is asking.
So maybe I'll venture a comment on that.
Okay, probably then. Nagesh, you have something to say on this?
I'll just try to venture a comment on that. So typically what we are looking to do with balancing, like Mani mentioned, is to somehow ensure that all the cells remain at the same levels of charge, so that the overall pack health is maintained well. So now when we say why is it so less, so the idea is to look at it and say, when do we do the balancing, and how quickly do we want to do balancing? So typically we balance once this drive cycle is done, and then the batteries have come to some steady state of rest, and then we balance them, and we do this slowly, because at the end of the day, balancing is also consuming energy, and we don't want to unnecessarily do a very fast balancing and it doesn't serve a purpose. So the idea is to do it slowly, and then allow the battery pack. Typically in a two-wheeler use case, overnight you are anyway not using the vehicle, so allow the balancing to happen slowly, so that next time when you are either charging the battery again or when you are using the vehicle, you typically try and have every cell at roughly the same level of charge.
Piyush, can I comment on this?
Yes, Avinash. Yes.
Yeah. Sorry. I was actually there was some problem. So our experience, typically the balancing happens at the time of charging, and when this battery pack is charging, at that time the cell balancing happens, because then you really don't have any problem, because if a battery is already charged and then you do later on sometime the balancing, you are basically losing the energy right there. So that's where we see that mostly people charge during the people balance during the charging. And when you talk about balancing current, I think the question was balancing current, right? In this case, so we see typically let's say 100 milliampere or 150 milliampere balancing current is good enough to do the passive balancing when you're charging the battery pack, basically. That's sufficient, because when you go above over and above 150 milliampere or 200 milliampere, of course possible, but then you need to have outside switching circuitry, then cost gets increased and things like that. So people comfortably choose anything between 100 150 max 200 milliampere passive.
So I will just add something to this. This is a very pertinent question, and I get asked this question almost on a weekly basis, right? I have never seen a battery pack being charged at less than 1 ampere. Yeah, when it should, and at that point in time, the balancing current is at max 10% of the charging current. Yeah. So for example, if the cell A, which we need to balance, you're supplying 1 ampere and you're taking out, let's say 100 milliampere out of it. So if for all practical purposes, while it's a very good thing to do, there is no denying the fact that we need to balance, right? But for all practical purposes, the way the chargers are designed, the way actual operations happen, in our operating conditions, balancing is just 10% of the current being supplied. Even when we are balancing, at the very least, you are supplying 9x the current to the cell compared to what you're balancing. So that's a practical reality. There is no, and to add to my 2 cents to this, we need to balance because we need to balance. If we don't balance, the cells will be worse off. That's the best we are doing. Yeah, you can't obviously take out 1 ampere, and if you start reducing the charging current to, let's say, 100 milliamperes, you will never charge the battery. So it's a necessary evil for us to have, unfortunately. So with this, we bring to an end to this this very interesting discussion. Thanks, everyone. Can I hand it back to Geeta?
Sure. Thank you so much, Mr. Piyush, and all the panelists for this informative discussion session. And it is also time to thank all of our guest speakers for sparing their precious time and cooperation for this event. A very special thanks to our partners for extending their support to make this event happen. Now, I would also like to thank each and everyone who has attended and joined us today for their overwhelming response. And with the positive note, we are ending today's event and promise to come back soon with much more interesting topics. Till then, goodbye, and most importantly, stay safe. Thank you.
Thank you. Thank you all. Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you. Thank you.
Thank you.
Bye.